Okay, example 4, it says find the lateral surface area and volume of the pyramid frustum shown. All right, so a frustum of a cone or a pyramid, that's where you typically see frustums. Just basically you take a pyramid or a cone, you chop the top off. So it comes up to a shape of same type. So we have a square on the bottom, we have a square on the top, for example, here. Okay, that's the frustum of this cone. All right. And the dimensions required, and there's lots of stuff going on over here. You have an upper base, a lower base, a perimeter, upper base, lower base, area, slant, height, altitude. So it's still got the same basic ideas of a pyramid. All right. We had area, perimeter, slant, height, height of a pyramid. We have area, perimeter, slant, height, height of a frustum. Right. But we have an upper and lower perimeter. We have an upper and lower area. All right. So the A sub 1. A sub 2, P sub 1, P sub 2. So when you come down to these formulas here, they're the same basic formulas. If you take a look, going back to this other page, lateral surface area is 1/2 PS. Well, the lateral surface area is 1/2 the sum of the P's S. And the total surface area is A plus 1/2 PS. The total surface area here is the 1/2 PS, right? The sum of the PS's, but then the sum of the A's also. Okay, the height one is just, I should say the volume one is completely different. It's 1/3 AH and 1/3 H times a whole bunch of A stuff over here. So this one's quite different, but the other two are pretty much the same. But you don't have to memorize formulas in this class. You have a formula sheet available to you. So know how to use it, but don't feel like, geez, there's no way in the world I'll memorize that formula, right? Because, I mean, it would be, with the number of formulas you're going to get in this chapter, it would be pretty time-consuming and cumbersome to understand and know all those formulas. So again, formulas you'll need will be usable in a formula sheet, but know how to use it. So looking at this, I want to identify those pieces. So I've got a lower base and an upper base. The base is a shape, it's not a number. Right? So the lower base is a 15-inch by 15-inch square. The upper base is a 9-inch by 9-inch square. Okay, they're asking me to find the lateral surface area and volume. Lateral surface area requires me to know that both P's and S, and the volume requires me to know all H's and or all the A's and H. So I basically have to know all this stuff up here to find what they're asking me to find. If I start off with the lateral surface area problem, what I need to know is what P sub 1, P sub 2, and S are. Okay. S is the slant height given to me right here, so S is equal to 5 inches. P sub 1 is the upper base perimeter. Well, the upper base is a 9 by 9 inch square, so it's 4 times 9 inches, which is 36 inches. And P sub 2 is the lower base perimeter, but the lower base is a 15-inch by 15-inch square, so its perimeter is 4 times 15, which is 60 inches. So you want to identify those three values, and again, the perimeter just requires a simple formula. Add up all the sides, or 4 times one side in the sense of a square. And the lateral surface area formula is right there. We use it with these three numbers. So the lateral surface area is equal to 1/2 times P sub 1, which is 36, plus P sub 2, which is 60, times slant height, which is 5. Okay. Order of operation determines that we have to add these together before we do any multiplication. So the lateral surface area is going to be 1/2 times 96 times 5. And at this point, probably grab a calculator out. 1/2 again is 0.5 times 96 times 5. And it comes out to 240. The lateral surface area is 240 square inches of this frustum. And again, that's simply the area of each side. So this side, this side, this side, this side. If we wanted the total surface area, we would add the square on top and the square on bottom to the lateral surface area. So you can see there's the lateral surface area right there. We simply add the top and bottom area to get the total surface area. So that's the difference between lateral versus total surface area in this. Right? They don't ask for total surface area, so that's not needed. Move on to volume. A volume requires to know the area of the top, the area of the bottom, and the height of the frustum. So the areas of 1 equals something, areas of 2 is equal to something, height equals something. Well, height, just like slant height's given to me, height is equal to 4 inches. So that's known. The top and the bottom area, once again, we're dealing with a square. Area formula for a square is length times width. So 9 times 9 for the top, which is 81 square inches. And 15 times 15 for the bottom, which is 225 square inches. If I apply the volume formula to the frustum here, I'm going to get the volume equals, it says 1/3 times height times area 1 plus area 2 plus the square root of area 1 times area 2. For me, particularly on this problem, this is the most complicated part of the formula, right? If I were to grab a calculator, just punch that little bit in, square root of 81 times 225, that comes out to 135. Even if that came out to a decimal, just let the decimal be there, all right? But the square root of that times that is 135. And inside that parentheses, I've just got a whole bunch of stuff being added up. So I would probably 81 plus 225 plus 135. Just go ahead and evaluate all that parentheses stuff. So the volume formula, even though it's all this complicated stuff here, looking, it's 1/3 times 4, simply times a number. All this stuff makes this one number 441. So evaluate all that area stuff to a single number and now punch it in your calculator. So it's 1/3. Most calculators type in 1/3, you simply type in 1 divided by 3, that's 1/3. As soon as you hit the times button, now you're back on top as far as the calculator is concerned. So 1/3 times 4 times 441 comes out to 588. Now as far as the unit's concerned on this is inches. Square inches, and this is inches to the 4th, but the square makes it square inches also. So all this is square inches. So inches times square inches make cubic inches. Also, you can just assume volume is going to be cubic units anyway, but just the formula itself is going to create cubic units. So 588 cubic inches is the correct volume of this frustum shown. Again, it's a little bit more complicated formula than the rest of the stuff, but it's the same basic process. The formula has unknowns in it. This tells you what those unknowns are. You identify what those things equal either by identification, hey, they told me the height, or by some formula, hey, it's a square and I need to find the area. How do you find the area of a square? All right. So that's what you're asking yourself each time. What type of shape is it? What's the area formula? Apply that area formula. Or what type of shape is it? Apply the perimeter formula. That's the perimeter of it. So it tells you what to find. You need to apply the correct formula or just by inspection find the correct number. Apply that the actual formula with the numbers you find to get the